So I'm going to talk a little bit about energy efficiency in historical buildings. Before that, I would like to illustrate the present situation about the energy efficiency subject in the EU. In 2014, then updated in 2016 and in 2018, the European Council agreed a new 2030 framework for climate and energy, including EU-wide targets and policy objectives for the period between 2020 and 2030, to be able to meet its long-term 2050 greenhouse gas reduction target. 40% cut in greenhouse gas emissions compared to 1990 levels, at least a 27% share of renewable energy consumption, indicative target for an improvement in energy efficiency at EU level of at least 27% compared to projections, to be renewed by 2020 with an EU level of 30% in mind. Support the completion of the internal energy market by achieving the existing electricity interconnection target of 10% to 2020 with a view to reaching 15% by 2030. What's the situation in Serbia? Serbia is a European country, but it's not an EU country, so it doesn't respond to EU laws and standards. It consumes up to 3 times more energy than EU countries in the neighborhood, arriving to 4 or even 5 times more consumption than the most valorous EU countries. The Ministry of Mining and Energy, Sector for Energy Efficiency and Renewable Energy Sources, established 2 main laws in 2013 and 2014 regulating the energy law on efficient energy use, and afterwards makes a lot of strategic documents like action plans, development strategies, annual energy balances, reports, and public insights. It's certainly not enough. To approach the EC goals, it requires an integrated strategy, both for existing and new buildings. Existing buildings represent a heritage of immense size, indisputably energivorous, with its own requirements connected to construction type of use, type of services, expansion of the offer services, and enhancement of tutelage. Let's say that in the contemporary conservation practice of historical buildings, the imperative is to process of reuse has been placed on different aspects of sustainability, ranging from authenticity and integrity preservation through minimum intervention and reversibility to energy efficiency. Great ferment, both of technological level and on designing level, around the topic of energy restoration found its place in the political agendas and programming strategies of most EU countries. And I would add also in the Serbian country. The special challenge is to develop the set of energy-saving measures to historic buildings, taking into account the uniqueness of the historically formed construction system as well as the need of the protection of cultural heritage objects. To improve the efficiency of existing buildings with evidence in the case of those recognized as cultural assets, it poses a fundamental question related to the risk of transformation that could lead to decrease in terms of its material and immaterial value. It is a very complex problem to deal with historical buildings, because not all the historical buildings are the same, and the historical buildings have changed, were adapted, and had so many transformations during their life. I'm going to show you an example. It's not a study case, it's just an illustration of what can be done with historical buildings and what is not being done with historical buildings. This is military headquarters building, Štabska zgrada in Pančevo, Serbia. It is It was built in 1930, and it lived through many changes and transformations. These are a few photos of how it was and how it is now, with the ground plans and the first plan. And just to know what we are talking about, it was built in 1930 as a military building. Then it changed its use to a grand hotel. Then after the Second World War, it was mostly in disuse. It was only the two big. Okay, no? Only these two rooms were used as restaurants. And then it was in 1980s and 1990s. It had some adaptation conservation works. And eventually in 2030 was completed the reconstruction of the roof and of the facade. Nowadays it has a few restaurants, some gallery spaces, and some commercial and office spaces. So very different kinds of usage of the building. For the purpose of this illustration, three models were developed. Model 0, made on the basis of existing conditions of the examined object. Model 1, minimum energy recovery measures had been applied, like replacement of the existing doors and windows, installation of a layer of thermal insulation on the interconnecting structure to the unheated attic space, ventilated facade with thermal insulation in the annex, and roof insulation. And in the Model 2, an additional to the already implemented measures in the Model 1, installation on inner coat thermal insulation. The second model was, we were discussing about it a lot, because most of the historic buildings, it is not possible to implement such a measure, because the inner coat could cover the paintings on the walls, or decorations, or other kinds of valuable heritage. So here are the construction of the building is made. It is made of bricks. The walls are very thick, actually, going from 78 to 108 centimeters in some parts of the building. We have a lot of plastic decoration on the facades. We have windows and doors with lunettes, with very decorated and very complicated. So we have a lot of elements that are very interesting, and that is very important not to alterate. So these are a few, I'm not going to read them, because they are just very standard sections of the original state and of the improvement measures, which are very basic improvement measures, I have to say. But as I was saying, this is just an illustration to understand how can we do a lot with not so many means. Since law in Serbia doesn't force you to do any kind of energy efficiency restoration in historic buildings. So if you want to, you can do it, but if you don't want to, it's not mandatory. So analyzing a little bit the question, we have total heat loss in Model 0, something above 4600 watt per Kelvin, reduction In model M1, something above 25, so it's a reduction of 45% of total heat loss. And when we are talking about specific heating energy demand per year, we are going from something about more than 127 to 56, and about 56% of reduction of specific heating energy demand per year. And in model 2, with the inner coat, we are improving those numbers by 11.8% respectful to M1, and by 19% respect to the M1 in reduction of total heat loss and reduction of specific heating energy demand per year. So, conservation and energy restoration are often based on a purely economic vision of recovery, far from considering the cultural value of the assets as a non-renewable resource. As the professor this morning was saying, the Brundtland Commission report, the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So, everything we do today, we must think about what we are leaving. So the historic building can be a design model, witnessing the possibility of interacting with the climatic context in which it is located, and from which to draw valid suggestions to propose again and update techniques that could allow an improvement of the energy performance of the building, with a consequent reduction of HVAC technology. So I made a little methodology, requirement strategies for sustainable restoration of historic buildings. So the choice of transparent materials with high thermal and acoustic insulation performance, to minimize the use of energy by maximizing the yield of HVAC systems, control and monitoring of installations, improvement of the daylight factor, installation of efficient and low consumption electrical and lighting systems, optimization of the indoor air quality, and choice of materials with low energy and low environmental impact. So to sum it a little bit, we have the context, which is investigation or the architectural artifact, which we can do in lots of ways. We can do like the most light way to do such an investigation is to visit the building and visually collect the data of the building. We can do some coring of the walls. We can use lots of techniques, electronic devices to analyze the building, which most of the time has layers and layers and layers of history, construction inside. Then the environmental investigation, the instrumental investigation, energy analysis, and consumption analysis, which all of those are parts of the cognitive tools that we have of our building. And then the data processing, like micro and micro climate data, materials data, and energy requirements. By combining those two, cognitive tools and data processing, we can pass to design phase and then establish relationships between context and artifacts in the morphological quality, ecosystem quality, and the last and not the least, fruitive quality. To have at the end a system of quality which allows us to control and to see the result of our work. Consumption reduction, indoor comfort, and energy efficiency can be achieved in historic buildings, respecting this particular characteristic and their historicity. If a multidisciplinary and interdisciplinary approaches, most of people were saying today, both theoretical and technological, guarantees the implementation of quality interventions specifically targeted to specific cases. Nevertheless, the finer intent is to provide indication that even if studied according to the characteristic of the different case studies can be replicated, which is a very important part, within the same context. Once the common matrices relating to the environmental characteristics, construction techniques, and materials have been found. This way of operating, while avoiding the standardization on interventions in some way favored by the legislation on energy savings, thanks to the indication of a series of interventions applicable to similar buildings, overcomes the case-by-case criterion that sees each historic building as unique and completely different from the others. So it is operative on all 6 axes that define and classify smart cities, smart economy, smart people, smart governance, and through sustainability and the end use of energy, and through ICT technologies, which you heard about half an hour ago, and directly in the sectors of smart mobility, smart environment, and smart living. So in the conclusions, it takes a considerable effort to tackle such a complex issue, which, while sustaining the different points of views of professional figures involved, manages to project itself forward to experiment with the possible solution visions. This vision is not necessarily resolutive, but tries to give an opportunity for a true and conscious reading of the problem, to contaminate the single monologues of particular knowledge towards a possible concrete direction and the discussion of the energy efficiency in historic tissue. We should implement as many approaches as possible, think and invent new proposals, new perspectives, and combine them together. This feature should not be an inhibition for the activity of designers and architects, but a resource and incredible stimulus to project our profession hereafter to assume the most sustainable tomorrow. And I would just like to add, this would be the end, I tried to be very synthetic. I would just like to add that we are now starting a project with one PhD candidate that is an architect, graduated in architecture, and doing her doctorate studies in mechanical engineering. And in the next 1 year or something more, we are trying to implement this methodology. To have some real results on historic tissue, and to see if everything works as we expect it to work. So that's all. Thank you.